Okay.
Do you
I
say
guess so.
hello or pedo?
Hello. Hello. Pedo. All right. So I'm just going to kind of follow the steps that I want you guys to do. I'm going to go through this slowly so you guys can kind of see. But obviously, my goal is for you guys to work through these steps and then say, oh, I can actually start doing this. So when you guys start doing this on your own, you're going to see what you can start doing quicker and quicker and actually skipping. Because again, we want to get to really being able to do this in your head. So first thing I want to do is sketch the angle, or step number 1 is sketch the angle. So sketching the angle. We know, guys, that halfway around the circle is pi, or 3 pi over 3, since that's our denominator. We need to go into 2/3 of that. So we know our angle is roughly going to be right there. There's our angle, 2 pi over 3. Is everybody OK with that? The next thing is we want to identify the reference angle here. So you can see that the reference angle is obviously going to be the distance between my terminal side and my x-axis. And you guys can identify, so if we already went 2 pi over 3 and halfway a circle is 3 pi over 3, then this reference angle is pi over 3. OK. The next step is to find the point on the unit circle for pi over 3. Now, again, this kind of comes into, you can reference your notes, obviously, for this. But again, guys, as I mentioned, we have our 3 standard points in that first quadrant. So our reference angle is pi over 3. And we know that pi over 3 on the first quadrant in the unit circle. Based on our notes and special right triangles, we figured out that to be 1/2 comma square root of 3 over 2. And then what I talked to you guys about question number 4 and 5 is we're really going to kind of like combine these together as far as evaluate the trig functions, again, based on our coordinate point. So we know, though, if this represents like half of the unit circle, this point is in the second quadrant. So basically, our coordinate point is not positive 1/2 comma square root of 3 over 2, but it's going to be negative 1/2 comma square root of 3 over 2. Now, I have a coordinate point that I know is on the unit circle. Now I can apply our new definitions. So that was my step, basically kind of like number 4. And for number 5, then, I can just do the sine of 2 pi over 3 is equal to the y coordinate, which is square root of 3 over 2. The cosine of 2 pi over 3 is equal to the x coordinate, which is negative 1/2. And then the tangent, which is not fun at first, but you guys will start noticing that these just keep on repeating themselves, is y over x. So it's a square root of 3 over 2 divided by negative 1/2. And obviously, guys, I'll do this the long way first, just so you guys can see what the answer would be. But you guys can start simplifying this from there. Remember, guys, you have a fraction divided by another fraction. Just multiply it by its reciprocal. Obviously, the denominator goes to 1. There's still a negative there, though. And then here, the 2's divide out. So you're just going to be left with a negative square root of 3. OK. Now we want to get to our reciprocal functions. So the cosecant of 2 pi over 3 is just the reciprocal of square root of 3 over 2. So that's going to be 2 over radical 3. I'll save myself the work and just write the answer in simplified form without a radical, or by rationalizing the denominator. My secant of let's write the angle. Secant of 2 pi over 3 is just the reciprocal of negative 1/2. So I can just flip that, and that would be negative 2. And then I'll do the cotangent down here. The cotangent of 2 pi over 3 is just this reciprocal. So now that's equal to a negative 1/2 divided by a square root of 3 over 2. And just like I did up here, I'll multiply by the reciprocal. Again, that goes to 1. The 2's divide out. And now I'm left with a negative 1 over the square root of 3, which I can rationalize the denominator, and I get a negative square root of 3 over 3. Okay? What you guys will notice, though, is, again, these ones that you're like, oh, man, that's a lot of work for one problem. But you guys will start noticing that they happen over and over again. So once you do them once, you're not going to have to probably do them the second or the third time, because they're just going to keep on popping up. But does anybody have any questions as far as the steps that I did to evaluate these? OK, your goal is to do all 5. If you guys can do it, it's a lot of practice. It's a lot of work up there. And you're probably not going to